Okay, so Dave kind of set the stage, told you what we were setting out to do originally, and I'm going to show you how kind of the technical architecture that we developed to solve this problem evolved over time. So throughout the history of the project, some of the ideas that we started with persisted and continued through. So kind of one example of this was the idea that we would use statistical machine learning as kind of the control plane of the data center, and that it would be these algorithms making decisions about provisioning and other things. So you'll see in a couple slides, on the first architecture slide that we presented, we had this idea of a policymaker. Over time, this idea evolved into the director, which is kind of now a phrase that we all know and love. And you'll see today we actually are going to be presenting a version of the director written by Peter and Beth that will be controlling the storage system, scaling it up and scaling it down in response to workload. Some other ideas were abandoned. I'm not sure who of you remembers the faux hawk. Kind of went out of style at some point. Some other actual research ideas were abandoned as well. So, we originally had this idea that we were going to scale up our own hardware infrastructure, first starting with FPGAs and then moving on to the black box. But we kind of realized we weren't going to be able to fit 20 black boxes on the volleyball court, so we abandoned that idea. Some other ideas actually moved on to kind of inspire other labs. So an example of this was we did a lot of work in the beginning of the RAD Lab on kind of managing energy as a first-class citizen in the data center. Here's some experimental results from a talk that Peter gave, I think, back in 2007, showing an experiment where we were dynamically adding and removing servers from a running website based on the server load. This kind of went off to become Local, which is a project spearheaded by Randy and David Culler. So here we are. This is actually the first architecture slide that we presented. This was from the intro talk back at the RAD Lab retreat in January 2007. It looks, kind of familiar still. Some things that you'll notice. We still had statistical machine learning as kind of the central data center policymaker. We also had the idea that kind of realistic workload generation was going to be an important part of the system. We needed some way to test our infrastructure to prove that our algorithms were actually going to work. So back then we had this project called AWE. Ruby on Rails, when the RAD Lab first started, we weren't sure if we were going to have to invent our own programming language, but fairly early on, we kind of decided that Ruby on Rails kind of fit this niche perfectly of a high productivity programming language that would let people implement compelling websites in, as short as a weekend. Another thing that we presented at this same retreat was this idea of where are we going to get these apps? So, grad students aren't particularly good at creating apps, but it turns out that undergrads actually have a lot of good ideas. So we had the idea that we would use these undergraduate computing clubs to create exciting apps using Ruby on Rails. We pulled in Dan Garcia to actually he has a lot of experience in starting up these clubs and getting the undergraduates excited. So he helped out with the beginning of this. And so here's some pictures of various clubs from that original slide. And it actually turned out that this went on to actually become a class that Armando taught. And Randy will talk a little bit more about the impact of this class later on in the day. But it was a software as a service course. The idea was we would use this not only to kind of teach the undergraduates about this kind of the new ideas that are coming in as software as a service, but also then to pick the best ones and bring them into the RAD Lab as graduate researchers who would build the applications that were going to motivate the infrastructure that the grad students were building. So here's another. So we listened to your feedback from that first retreat. You guys told us what you liked and what you didn't like, and we listened to quite a few of those ideas. I'm going to point out some of the ones that I think were particularly impactful. So first of all, we had this kind of idea that shutting down was going to make things more reliable, but Google told us no. We have good things to do with our computers. We spent the money. We'd rather do batch jobs than turn machines off. Another idea that we had was ramp for system emulation. We'll talk of kind of how that evolved in later slides, and Randy will talk about what ramp went on to do later, but we decided to abandon that as the primary way of testing out the RAD Lab's infrastructure. Another idea was we needed to have some kind of consideration for storage aspects of the data center. In that first architectural slide, there really was no storage solution. I guess we were planning on using relational databases, but we decided that wasn't going to work, and you guys pointed that out to us, and we'll talk about what we actually ended up doing to solve that. And finally, you said some kind of specification-driven data center design. Kind of the way that we do this ad hoc where admins SSH into machines and set up configuration files by hand isn't going to work for a system of this size, especially if you only have one operator. So at the next retreat in May of 2007, we significantly revised the slide. Some things that changed include this idea of the declarative data center spec, which was the idea that you would write this one spec that described all of the services that you wanted to run in the data center, and then the system would compile this down to what actually needs to run, and the director would figure out the provisioning. Another thing that we kind of added to this slide was the focus on a typical developer as the end user of our technology. So you don't need to be an expert in scaling who has been building these systems for many years in order to use it. You should just kind of be a typical developer who understands Ruby on Rails but doesn't really know too much about running a large data center. Additionally, we added the director in this slide kind of as the statistical machine learning based controller of the data center. And another kind of key addition, I think, in this slide is the importance of monitoring data as providing feedback to the director. So moving on to January of 2008, we have the next iteration. Things are getting a little bit more complicated. Things that you'll see changed. We've now added a unified tracing framework. Ari is going to talk kind of about the evolution of this component specifically in the next talk. We also have the idea of the non-relational data store. So this is the first retreat where SCAD showed up. And I'll kind of talk why it makes me cringe to call it non-relational later. But we decided that maybe wasn't a good idea, but that we did need some kind of scalable storage abstraction. Additionally, in addition to using AWE kind of to drive the load on the system, we also added this idea that we would use it to construct predictive models that we could then use later for provisioning information. And Beth will talk about how that's important in her director talk. And kind of the other big thing that changed at this retreat was we no longer said that this was just a 5-year mission. We said that this is going to be a 5-year demo. At the end of the 5 years, we are going to show you this system working, and that's what we're here for today. Some other things that happened around this time. Here's another slide from Armando's class. At this point, by the fall of 2007 and the spring of 2008, we actually had some undergrads who had built projects, and we had started bringing them into the lab as research assistants. So in the winter of 2008, you started giving us some more feedback. You started to question our story a little bit more regarding scaling. And so we kind of basically what you said is for our results to be credible, we're going to have to run some of the experiments on thousands of nodes. And buying more black boxes isn't going to work. Randy, I think, is going to talk a little bit about just how much of a pain installing the one black box was. And clearly that's not a good idea for research since we would only be using it for periodic stress testing and it'd be costing us money all the time. So the question was, how could we scale up research without this large investment? Luckily, right around the same time, utility computing came about. And this was in the form of EC2. So here's a slide, I think, from Dave's talk, the retreat of June 2008. EC2 was awesome. It allowed us to have 1 hour of 1,000 cores for $100. That cost elasticity really kind of enables a different kind of research that we weren't able to do before. And with these prices, even academics can afford it. Looking at a timeline of our Amazon usage, right about here is where you told us that we needed to start using cloud computing in order to scale our experiments. Just 2 months later, we started running performance experiments on EC2. By the middle of February, we were actually doing the largest scale experimentation on Hadoop that I know of at the time, and I think some of the largest scale experiments that were run by any academics at the time. Right around this time, Andy and Matej got a phone call from the AWS team because we broke their network. So we were not only some of the first large-scale customers, but they were helping us to prove our technology, and we were helping them to prove their technology. And then right here you can see there's a dip-off in the work, and that's because that's when they submitted their late scheduler paper to OSDI. So moving on to the summer of 2008, we made relatively few changes to the architecture at this retreat. The first one is we kind of added EC2 at the bottom of the stack. And the second major change was, I believe it was Bill Belosky told us that Homer Simpson was probably a little bit too low of a bar to aim for as far as a developer. So we switched to using the Elvis persona at Microsoft. So for those of you who aren't familiar, Microsoft has these ideas of different personas, which are kind of different classes of people that you develop your applications towards. And Elvis is kind of your typical developer who kind of understands things, but maybe doesn't have a PhD in scaling up systems. So another cool thing that happened around this time, in the summer of 2009, we actually started to demo pieces of our technology. So this was when we did one of the first director experiments. This was a slide from one of Peter's talks. Basically, the idea was that we would do kind of some online active exploration of the space of different requests that you could make against the different Ruby on Rails servers. Use this to train a performance model. And then based on that, you could predict the resources that you would need in order to meet your SLOs for some given workload. Kind of another cool aspect of this work was the idea that you could request new virtual machine types as they became available on Amazon and then benchmark them so you could understand what was optimal for a given workload. Additionally, we had our first app. We presented it at the summer of 2009. This was Scatter. This was a Twitter clone written by some undergraduates in Ruby on Rails. This was backed by the first version of SCADS. This is back when SCADS was only a key value store and supported nothing else. And kind of the goal of this was to understand how app developers would use SCADS, both from a productivity and a performance standpoint. And kind of the key takeaway that we got from this was developers have a really hard time writing apps against key value stores. You have to maintain your own indexes. Every time you change something, you have to rewrite everything. And you'll see this actually did shape our architecture moving forward. And Crystal's going to talk about the Pickle work that came out of this revelation. Another cool demo that we showed off in the summer of 2009 was Chukwa. Ari's going to talk about this in his monitoring talk, but we showed Chukwa collecting logs from many systems and actually plotting metrics in near real time on a dashboard. So, summer of 2009, we did a bunch of major changes to the architecture. Thank you to Armando for originally building this build slide. And there we are. So, winter of 2010, we kind of presented the RAD Lab architecture version 2.0. Some key changes from past ones. We introduced Pickle as a high-level declarative query language that allows developers to express kind of performance-safe queries in this high-level language, but still getting kind of the performance guarantees that you get when using low-level gets and puts against a key value store. This work was presented at SOC last year. We also have the idea that the Pickle would actually give feedback directly to the developer using statistical machine learning kind of to explain which queries are expensive and give them ideas about how these cardinalities are going to affect the overall response time of their application. Additionally, we had this idea that we were going to have specialized directors for controlling stateful and stateless systems. Here's another example of some research work that Beth presented at FAST last week on the director for our storage system. Console log mining, which Wei is going to demo next, was presented at OSDI in 2010 as kind of feedback on anomalies to the developer on things that might be going on in the system that they can't necessarily see due to the massive volume of console logs. And Mesos. This is the first retreat where we presented Mesos as the global cluster resource manager, and Matei is going to talk about that more later in the day. Another kind of key thing that we added here was the idea that batch and analytic workloads would be sharing the same cluster. This is another thing that we'll actually be demoing today. And finally, we presented new machine learning frameworks in addition to MapReduce that allow you to do efficient iterative computation over large data sets by keeping the information in memory. And this is Spark, and Matei has a presentation on this later as well. So here we are today, spring of 2011, final demo. I'm going to declare mission accomplished. We're going to be showing you two applications developed by undergraduates. Gradit, which is a GRE studying tool with a social component, and Scatter, which is a clone of the popular website Twitter. We have 8 different grad student projects which have actually been integrated to work together within the last 3 months, representing a rough estimate over 80,000 lines of code. And we're going to show this running on hundreds of instances on EC2, scaling up from 0 to hopefully thousands of requests per second by the end of the day. So kind of here's the final architecture that you'll be seeing today. Some kind of things you'll notice that are different from the last version I showed you. The declarative data center spec has been replaced by DeployLib, which is a Scala DSL for scripting cluster deployments and kind of controlling them interactively through a console. Data center replay will be presented by Gautam as a way to deterministically replay bugs that you see in kind of complicated distributed systems. And Crystal will be showing a little bit about some of our ideas on where we're going with using statistical machine learning to provide insight at compile time for Pickle queries. Rain has been added to the top of the stack. Rian will be talking about this later, making realistic workload against the applications, causing the system to actually scale up. And finally, we have a web app director, which was written by Andy Konwinski, that's going to dynamically scale the web app tier in response to load. And another really cool part is now Spark, instead of just being able to read data off of HDFS, will actually be reading data out of a live SCADS instance. So there's another example of integration between the projects that has occurred recently. And Justin will be showing how you can use this to do Twitter spam filtering on top of the data that's stored inside of SCADS. And finally, Ari is going to show us the dashboard, which is going to show all of the metrics from the running system so that you believe us that there really are hundreds of servers somewhere in a data center running, making this experiment happen. So just in summary, the RAD Lab final demo, it's running live right now on EC2. If those of you who want to kind of see the technical dirty details, you can go and check out mesos.radlab.net, where you can see the cluster manager and all of the resources that are being allocated. You can view all of the logs and whatnot. Dashboard.radlab.net, Ari's going to talk about in just 2 talks, show all of the metrics. And I think a really cool part of this demo that was kind of enabled by cloud computing is that you can run this demo yourself. You don't have to believe us that it actually works. You can get a credit card and check out or make an AWS account and download the source code and run this yourself, either concurrently or at some other time with the final demo today. And there's even documentation, thanks to Andy. But wait, there's more. Somebody promised you that a single person was going to go from idea to creation in a single weekend. And we did that this last weekend. We solicited suggestions for apps, and John Wilkes gave us an idea which inspired the app that we ended up building. Basically, the idea is that some companies might get many, many job applications, maybe 75,000 in a single week. And dealing with this sometimes presents scaling problems. So Carl's going to explain the full app, but we came up with basically kind of a mashup between a system that allows people to submit their resumes and hiring managers to see who's available with kind of a dashboard that shows all of the people streaming by as they are interviewed and hired. So here's an example of Carl's long weekend. It involved a lot of Coke, some pizza, of course some architectural diagrams, and what we ended up with was comrades. Yeah, pretty clever, huh? Yeah. So with that, I'll take any questions before I pass it off to the undergrads to show you off their cool apps. So anything, or should we just see the apps? Okay, let's see the cool apps. Thanks.